Hi, everyone. My name is Adifemi Michael. I'm a DevOps engineer at Swisscom. For my topic today, I will be speaking on testing with LocalStack on Terraform. I'll be giving you a walkthrough on what led me to this tool, and then I will also be discussing about how I use this tool day to day, and also some couple of funny stories as well in between. So yeah, let's start with the highlights. For my table of contents, I have not so much. Of course, I'll introduce you guys to Terraform. I'll discuss what LocalStack is, and also why LocalStack, why is it useful? And then for a quick one, I'll definitely do a demo of how to use LocalStack and do a quick demo of what I do with LocalStack using some couple of Terraform configuration, and then also how to set it up as well. So introduction to Terraform, right? Terraform right now shouldn't be like a less popular tool, especially in the infrastructure as code world. And why did I say this? Because for me personally, I think it's the most powerful tool out there, especially when it comes to infrastructure as code. One of them is because it is cloud agnostic in the sense that it does not matter the cloud provider. Terraform works for it. There's definitely some sort of Terraform configuration that is available on Terraform docs, HashiCorp documentation for Terraform that works for it. So talk about AWS, GCP, talk about Azure, talk about DigitalOcean, talk about Kubernetes. Everything is up there in HashiCorp Terraform documentation. So, like I said, Terraform is an open source infrastructure as code software tool. Yeah, and it's developed by HashiCorp. So basically, the whole concept is write once, run a lot of time, and then Terraform, unlike other languages, it uses something called declarative configuration language, in the sense that Terraform config itself is declarative. Like I said, you can use this to describe infrastructures, create infrastructure on your cloud provider, regardless of the cloud provider. Yeah, that's about it for Terraform. And now I want to look at what is LocalStack, right? Which is the big giant in the house. So a quick history of how I discovered LocalStack. For the company I work for right now, which is Swisscom, I was given a task one time regarding building up some sort of configuration. And I started thinking, how do I test this configuration locally? This time, I knew I don't want to create a new account on AWS, which I could do using get a new card and create a new account and then just start using it. But I could remember well in college that AWS actually put me in debt, which is quite funny because yeah, I have these gifts that shows that. So I could remember why in college AWS put me in debt. So I started looking at how do I get like something that works locally and I can use to deploy resources. Then comes LocalStack. So LocalStack is an open source project that provides a local, more or less like creates a local AWS cloud stack for you on development, and most of the time is used for testing before you push your code to production or whatever. So it depends on how LocalStack, how you set it up. I will also show you like how to set it up or how I set it up and how you can set it up as well. And you might be wondering, well, why do I need this? You're right. Like I could easily just, connect to my AWS account and just use this, or connect to my Azure account or whatever and just use this. Why do I need this? One, cost effective. So with LocalStack, you don't have to worry about cost, right? The only cost you have to worry about is your CPU, because it is local to your system. Also, faster feedback. And what do I mean by faster feedback? When you write your configuration, most of the time, you open a pull request as a developer, right? You open a pull request, someone reviews it, they confirm your configuration. You might attach some sort of screenshots to your pull request to show that, oh yeah, it is working fine. But how about if I can test it locally on my end, test it in a particular environment or with a particular account, and then see what I'm testing before I say, okay, let me try this on staging, or let me try this in development or whatever. Also improve testing. Imagine if you're making some sort of change, maybe you're writing some sort of Lambda, and then you want to just quickly test the Lambda, see the output. You don't want to go in the loop of you running Terraform apply, deploying to AWS or AWS, for instance. I'll be mentioning AWS because I've used this with AWS a lot. So deploying to AWS, you don't want to wait for the test to pass and then you seeing the output. Everything can be computed right there in your local environment. Also reduce complexity. You don't have to think about the overhead of setting this up. So I'll give a quick demo of how I use LocalStack. This is just a simple demo, and I'll be pushing this code to GitHub. So definitely, I will share the link as well to how to access this code on GitHub. So you can set it up locally in your environment. I've added some sort of little bit of README in the file to aid you in setting it up. So yeah, let's get ready to go to space. Let me increase this a bit. So, like I said, I'm just doing the simple stuff. So I have a Lambda function, and what it's just doing is just printing out, oh, this Lambda was successfully triggered, and also welcoming you guys to HashiCorp deploy. I have a main.tf, something simple, no crazy stuff. So I have a resource that is creating the Lambda function, right? And in this place, I'm passing in the handler. The source code hash is my zip file. What else? The file name is source.zip. Then it gets deflated in my Lambda. What else? I'm creating an S3 bucket. I'm calling the S3 bucket test bucket 070. Of course, I'm making my ACL public read. Of course, you can make it private read, but then you have to go through the overhead of making some sort of configuration to make sure the bucket is readable the bucket is readable by your Lambda. I have an S3 bucket notification, and this is just going to trigger the Lambda when I create a file or push a file to my S3 bucket, right? I have the Lambda permission that just says, okay, allow the Lambda to be invoked by S3, basically. So I'm creating a CloudWatch log group. And why do I need this? Because I want to see my logs. I want to see this print statement that I'm passing in my logs. What else? I'm creating a role. Of course, this works, but I have to remove it so I can do some sort of code separation between the policy for the role policy and whatever policy I need to create. Yeah, so I'm creating a role. Of course, this rule will actually be assumed by Lambda, so something simple. Passing the role policy as well. Which is just going to read from this resource and allow all action, basically. And in this place, I'm creating an action for my also adding an action for the IAM policy. And what this is just going to do is going to allow us to create log stream because I need log stream, and I also need to put the log event, right, into my logs. The last part, I'm just attaching my role, which I created, to the policy, to this login policy for the Lambda function, basically. So LocalStack. Now that is for the Terraform part. For the LocalStack part, so with LocalStack, you can run it in a couple of ways. You can either run it in Docker Compose, you can run it in Docker directly, or you can install LocalStack locally in your environment and then run it that way. But for this demo, very quickly. So yeah, and you can visit LocalStack quite direct, localstack.cloud. And in their docs, getting started, installation. So in their docs, you can see you can install LocalStack CLI, and they also have alternatives. So you can do install the LocalStack desktop, the Docker extension, the Docker Compose, which is the one I'm using. You can install it with Docker. If you are conversant with the Kubernetes environment, you can also install it via mchat. But for me, I'm just going to install this via Docker Compose, and then I'll show you some of the configurations that I'm passing in the Docker Compose. So back to this place. So it's just something simple, right? I know my image is LocalStack. LocalStack is actually defined here. So I'm just doing a copy and paste of what is here actually into my Docker Compose file, and that's just it. So I'm running this debug level just so I can see my output, connecting the Docker host to the container, basically. And then lastly, I'm setting some volumes in which LocalStack will be run. So now let's test. So because I've, of course, run this before, so my Docker Compose up will be quite direct. So of course, as you can see, saying LocalStack version 3.0.2, which I think is the latest, and the container ID and some weird outputs. But the interesting thing about this is you can also visit this URL locally on your environment, which I will show you as well. So let's go through the steps. First, we have this. Oh, okay, let me delete this file so that we can start from Terraform init, and then we don't have to do this. So, of course, with Terraform, right, you first want to initialize your Terraform configurations using Terraform init, right? And before that, you might need to export your access key ID, your secret. As you can see, I'm just passing a random secret and a random access key ID. So this is allowed. Just random values, we don't care. Initialize Terraform configurations. Yep. So this one Terraform init is going to initialize Terraform. The only thing I'm doing here, or that is needed here, is the HashiCorp AWS. And I think that's just it. So this should be really, really fast. Yeah, that's done. And then I'm going to do Terraform plan. Don't forget, I've exported my my access key and my secret key and my region, and as you can see, yeah, it's just a random generated string. Terraform plan, which should show us what is about to be deployed, of course. Should be quick. Let's hope so. Yeah. So this shows us that, yeah, we are going to deploy. So this shows us that we are going to deploy CloudWatch logo policy function. Of course, we need that. IAM role, of course. Let's see, role policy, of course. Attachment, of course. The Lambda function, of course. Create the source code hash for us. Okay, good. Lambda permission, of course, the S3 bucket, of course, and the bucket name, 070, of course, random. What else are we deploying? Some additional information here. The bucket ACL, not really needed because we just passed that the ACL should be public, so cool. Notification, what we trigger the Lambda, basically. And if you look at the output here, it's saying, oh, the account ID is not found for that provider, we don't care because we know we are not deploying to a particular AWS account. So this is just running locally, so we don't care about this. And then I'll run a Terraform apply these changes. And this should also be quick. And when I apply the changes, let's look at this place because I've put auto approve here. In the output of my Docker Compose up, you will see some sort of like out because I pass in this debug, so I can see some sort of output here. So it's creating policy, good, create rule, good, get rule, good, get policy, good, showing me S3 bucket, or you can read S3 bucket, S3 bucket policy. So I didn't pass this, so that's why I say no such bucket policy. I didn't set up cause because I really don't need it to test my Lambda. So I didn't set up bucket website. I don't need this. I don't need all this stuff that is showing 404 because I didn't set them up, obviously. And bucket tagging, of course, I didn't set this up as well. So good. Yeah, all this looks good. Added the permission. Okay, all this looks good. Let's go back to our Terraform apply. Okay, so apply complete. Like I said, we don't care about this. Yeah, because we are just doing this locally. And if you check my provider.tf, I've passed in some, what's it called, some access key, secret key. Actually, I don't need to do the export because I've passed it in here. And I passed in some endpoints. Honestly, the only endpoints I need is for CloudWatch logs because because I'm using all this in my code. That's why I'm passing in the endpoint here. So I'm passing in the endpoint for CloudWatch because I know I'm using CloudWatch logs, IAM, Lambda, S3, and STS. This is also available in LocalStack documentation. And also I'll show you what are the current service that they have available that you can use out of the box. Okay, so now this is done. Let's go back to the README. Let's see if I can make this good. No. Yeah. So now we've done Terraform apply, right? Let's do something interesting. Yeah. So we've done Terraform apply. Let's copy a file to S3 bucket. So I have this file here called file.md. So let's copy that to S3 bucket. And if you notice, I'm passing in endpoint URL, right? And I'm pointing to localhost 4566 because the port I'm exposing is 4566. And I'm passing into this bucket. And as you can see, upload complete. Let's list the files in that bucket to see what we have there. As you can see, file.md is present. Okay, so the last part, which I'll show, is to check the logs, our CloudWatch log. So first, I need the log stream name. So I can just do this and to get the log stream name. So the log stream name is, this is what I need. And then I can upload my README here to use this log stream. I've already written a query that allows me to pass the log stream, the content of the log stream to a file called log.json. So I'll just copy and paste this query. Of course, it's going to be in the README, in what I'll push to the GitHub repository. And then I can run this. And this is going to create a log.json file for me here. And if you look at my log.json, right, this is the logs of the, this is CloudWatch logs. You will see it as a start request, just normal CloudWatch logs. And then for Lambda. And then you can see Lambda successfully triggered welcome to HashiCorp, which was what we defined here. Of course, if you want to make your Lambda complicated, you can make it complicated, adding more functionalities, depending on what you want to do. You can do that with the Lambda. Last but not least, which I promised I was going to share, was I've seen sometimes people mistakenly, and of course you are also seeing the output here as well. You are seeing the output of everything that we are running. You can see the output here. Last but not least, like I was saying, I've seen people mistakenly close the tab that is on the Docker Compose. So if you close this tab, it deletes the whole thing. So you don't have access to this to this endpoint, to this bucket, and then you don't have access to the resources that you've created. So if you don't want to close this, of course, you can run, if you don't want to mistakenly close this, you can run Docker Compose in detach mode, which is just passing the -d flag here. And then you have Docker Compose running in detach mode. I promised I was going to show some of the services that they offer, or that they are currently allowed in AWS. So when we go to user guide, local AWS service. So all the service that have about 5 stars, or 1, 2, 3, 4, 5 stars means that they are fully supported. This one means that they are partially supported and whatnot. So you get the gist. So from here, you can see the support ACM, the support Amplify, the support API Gateway, and they will also tell you what they support in that particular service. For me, you will see I'm using, they also support Athena, which is interesting. But also notice that some of the service has something called Pro at the front, which means because LocalStack has 2 versions, they have the community version, which is what I'm using. They also have the Pro version, which is the paid version. And PS, I don't work for LocalStack, but I just enjoy their tool, which is why I'm talking about it. So I'm not trying to push LocalStack to you. But they will have the Pro version and the community version. And the Pro version, you get, of course, much more enticing thing. The community version, you get enticing stuff, maybe less, but that's fine. For me, I'm using S3, which is community version. Yeah. So for me, I'm using S3, which is the community version. So we are all good. If what you're working on doesn't require the Pro version, then yeah, I think the community version is much more than enough. And I think there's also a way where you can actually use the Pro version. I don't know. But yeah, that's what they offer. These are all the tools they offer. They have some sort of integrations as well with all these tools. You can use their they have integration with running it in running their configuring all their environments in the command line. So yeah, it's quite a powerful tool to use. Honestly, for me, it's really, really nice to use, especially given the fact that I don't want to always create something on AWS to make it work or to see it work. So this is quite direct and just cutting off straight to what you need to do. Going back to our presentation. So yeah, we have that deployed, and like I said, all good. Everything is deployed fine. We were able to what's it called? Push a file to the S3 bucket. We were able to get the logs, see the output of the logs. Yeah, which is more or less what is needed in LocalStack for my demo. So overall, what did we learn? 2 things. We learned that 1, with LocalStack, you can test your Terraform configurations, right, with the community version. And of course, if you're subscribed, you can test it with the Pro version. We learned that you don't have to be in debt when you are running resources on AWS, so which include cost savings, like I said. With this, you can provide faster feedback to someone. If you're doing peer programming in your office, you can also use this to provide faster feedback. You don't have to wait for the person to deploy before you see the changes or whatnot. This can be seen live. This also helps with testing as well. So instead of writing code, writing code, applying the changes directly to your account, you can write and apply the changes locally. So it's portable in the sense that, I mean, I can just literally send this code to another person, and then they run the code, they get the same output, because it just has to be Docker Compose up, and then that's just it. Also, like I said, complexity to just reduce overhead in general. So with that, I think that comes to the end of my talk. So yeah, thank you so much for listening. Let me know if you have any questions. I'll be in the chat looking out for questions. Thank you.